So in this section, we know that the length of the pen is 12 centimeters, or better yet, 0.12 meters, and the charge by the rod is -2 nanocoulombs, or -2 times 10 to the -9 coulombs, and the distance from the midpoint of the pen is 18 to the -3 meters, and there are 5 numbers of segments. So for part A, the length of each segment is calculated by DL equals L over N, which equals 0.024 meters. And the amount of the charge changing Q on the small piece of the length, DL, is the changing Q, which equals the charge per unit length times the length of the piece, equaling -4 times to the 10 to the -10 coulombs. Now we can allow DL to be the length of each piece of the rod, and the changing Q to be the amount of the charge of each piece, and that would just basically mean that the charge per unit length of the rod is equal to Q over L, and the amount of charge on the small piece of length, DL, is equal to the charge per unit length times the length of the piece. So now for the section D, it asks us to write an expression for the number of pieces in terms of length. So we can basically use that equation DL equals L over N and rewrite it as N equals L over DL. And the next section asks that we can write another expression for the amount of charge on each piece of the term of the length of the rod, and the length of a small piece, which equals to the charge per unit times the length per the piece. So, like, the reason we did the following questions the way we did is basically because when you're solving for an electric field with the distributed charge, it's probably a good idea to just apply the superposition principle. And we know that as dividing the charge distributions into small pieces, then we can draw out the change in electric field, and then we can write an expression for the electric field, and then add the distribution of the pieces. And that's exactly what we did here. So since we're looking for the electric field of a pen, we could just apply the same values that we would use for a rod, meaning that the distance from the hard point, from the midpoint of the rod along the line, is perpendicular to the rod. With Q being the total charge, L is the length, and the directions will be flowing either way. Like, it just kind of depends on the sign. Is if it's negative or if it's positive. So we use the equation E equals 1 over 4 pi E naught times Q over R times square root R squared plus L over 2 squared. And that basically gives us -4 49,690.3995 to the N over C.